To another video, Math Magic with Jen. This is a video on adding integers. So this will be our last video on integers. This one we're adding. And I'm going to introduce a game that's from the Common Core textbook called the integer game and a method that I like, which is called the chips method. So let's go ahead and get started. So adding integers. The first arithmetic skill students learn with integers is adding them. The Common Core textbook loves them some number lines. If you watched my last video, the last two videos, you will know this. And they stick with it. There's nothing wrong with number lines other than it can get a little bit messy. And I want to show you an alternate way of adding integers, which is called the chips method. I will say this though, number lines are great for visualizing what's happening here, and they really like to focus on what pairs of numbers add to zero. So they want students to realize the opposites are going to add to zero. So a 2 and a -2, a 5 and a -5, a 7 and a -7, those are going to add up to zero. So to help them kind of learn this idea, they do what's called the integer game. So it's pretty simple, but you can definitely make it harder or more complicated depending on what you like or don't like about it. It's just a card game. And you can have actual physical cards that you make, or you could just have a worksheet illustrating them. So, for example, in the textbook, they'll have things like Jenna's hand and Jay's hand. And as you can see, there are two cards. So, asking them, what's the sum of their hands? So the cards are pretty simple. We've got the numbers 1 through 10. Technically, you can make larger digits, like if you want to go 1 through 20, but they try to just keep it simple and do 1 through 10, both positives and negatives. If I was going to make a deck of cards, I would probably have two sets of each. So like two sets of positives, 1 to 10, and then two sets of negatives, -1 and -10. That's just my idea. So 40 cards would be a deck. Some older YouTube videos that I made years ago where I attempted to use um, just a set of standard playing cards where red would be negative and black would be positive. My only real problem with that is that you'd have to make sure everyone agreed that red is negative and black is positive. And there's no number one, you just have aces. And then I had to take out all of the face cards. So maybe it's a good idea, maybe not. I would probably go ahead and just create my own little simple set. Okay, so the directions to this can be modified, but basically students are handed out cards. And where the directions modify is, are they just always taking a card? So they just have a giant pile of cards? Or are they discarding as well? So are they taking a card and then getting rid of a card? So that's where it can become more complicated. For the most part, for the worksheet type problems, they have them just keeping all their cards. So here, Jenna would just have these two cards and Jay would just have these two cards. And then it talks about picking a next card. Okay, so what we want to do, the goal of the game is the winner is the first to get to zero. Okay, or when time is called, whoever is closest to zero. So right now, what we would have Jenna and Jay do is add up their hands. So they need to know how to add 3 and -5, and Jay needs to know how to add 3 and 5. Okay. And so this is where the adding comes in, is do they know how to do this? Now I'm guessing Jay knows how to add 3 and 5, but does Jenna know how to add 3 and -5? And then know which card she needs in order to get to zero. Okay, so let's talk about how would Jenna add her hand. Okay, so as I already said, the Common Core textbook loves number lines. So how this works is that if a number is positive, you jump to the right. If a number is negative, you jump that value to the left. And you start each jump where the last ended. So, for example, for Jenna's hand here, if we're going to start with a +3 and then I'm going to add a -5. And just so that you know, by the way, a lot of times the way this will be written in a textbook is 3 plus, and then they put parentheses around -5. So those parentheses are just there to highlight that, yes, that's a negative number. Okay? All right, wonderful. So what we could do is Jenna could figure out her hand by starting at 0 and first jumping a +3, which lands her at 3. And then she's going to jump backwards to the left 5. And so if we count 1, 2, 3, 4, 5, we land at -2. Okay. Now, order doesn't matter. We could have started with -5 first and then added 3. And so that's what you're going to see here is starting with jumping back -5. So I'm jumping backwards 5. And now I'm going to jump forward 3. 1, 2, 3. And oh, by the way, you can do baby hops. So you could just go 1, 2, 3 that way. And you could count 1, 2, 3, 4, 5. So you don't have to do gigantic jumps. You could just count every one. So definitely easy to modify. Okay, where we land though is our answer. And so you'll see it doesn't matter if we went 3 and then -5, or if we went -5 and then +3. Either way, we ended up with the answer of -2. Okay. So let's practice a little bit more with number lines. So here it says in the integer card game, you drew the cards 2, 8, and -11. Your partner, I think that's supposed to be gave you a 7 from their hand. What is your total? So it wants us to model our answer on the number line below. So if we want to just literally take it as 2 plus 8 plus a -11, you can have the parentheses or not, and then plus 7. Let's see where we end up. Okay. So rather than do big jumps, I'm just going to literally do little jumps. So here I'm going to go, there's my +2. Okay. And then I'm going to go 8 more. All right. So all of this is +8. Woohoo. Okay. So right now I'm at a +10. Now I'm going to go backwards 11. So maybe we feel pretty good to go back 10 all at once and then just back one more for back 11. So there's me back at 11. Okay, you ready? Now the last one, we have to jump forward 7. Okay, so let's see. I'm going to try and jump forward all at once, but here's the nice part about these number lines. I don't even know if you noticed, but my number lines have lines straight up like a grid, so it makes it a lot easier to count as you jump. So here, as I'm jumping, I'm basically counting 1, 2, 3, 4, 5, 6, 7. Do you see how I did that? I'm going to do that one more time. 1, 2, 3, 4, 5, 6, 7. So here's my big jump. Okay, bit messy, right? You're not wrong. I'm going to show you what I like, a different method that I like a little bit better, that's a little bit cleaner. But when all said and done, we can use this number line method. The total of my hand right now is the number 6. When all said and done, it's going to add up to 6. Okay. Assuming you kept all of your cards. So I got 4 cards in my hand. What next card would you need to get to 0? So if I had a 5th card, and I'm going to have all 5, what do I need to get to 0? I need a -6. I need that card that's a -6 to get me to 0. Now, we could talk about what 2 cards. So, like, do you need a -2 and a -4? There's all sorts of gaming that we can do. But at this point, we will just want to keep it simple. 1 more card to win to get to 0. I need a -6. Okay. Now, if you thought those number lines were messy, let me show you that same problem here. Oh. This is in the teacher resources. I borrowed this from the public archive for Common Core, the problem I just modeled for you guys. And this is their answers. So, I want to point out a couple different things. One is the fact that they don't have those lines. So, like if I go backward for a second, these lines help way more than you know. So having some sort of grid above really can help count and jump and see where you're landing. Okay, so that's point one. The next point that I want to speak about is the fact that none of these are labeled. So it's really hard to see what's going on. So what I would probably suggest my students do is that they need to at the very least label that this one's a +2. This apparently is a +8. And so we are currently landing at 10. I'm going backwards 11, which is what's landing me at -1. And then I'm going forward 7. And my final answer, if you didn't think that was a big enough mess, my final answer is I need to come down and find one. So I don't like to bash the Common Core textbook because they have a lot of great things, but I feel like they missed the boat on this one. It is very, very, very messy and not clear at all. So just pro tip, if you're going to use number lines, I think that little grid really helps and have your students label the arrows because otherwise it's really hard for them to know what the heck they're doing. Okay. This is my preferred method to teach students how to add integers. And it's really simple. It's called the chips and disc method because technically you can use the discs, the little plastic discs that are yellow on one side and red on the other. And you could have like the yellow side be positive and the red side be negative or so you can actually technically, have two colored chips on a board on a sheet of paper, whatever, to do the same thing. However, you can also just use a pencil and paper and it'll still work. So all you need is your students to have a rectangle that they draw on their paper with a minus sign and a plus sign. Okay. So this is our negative side and our positive side. And for each positive number, they're going to draw dots, chips, circles that represent that number, and they're going to do the same for the negative. So what's happening here is Jenna has a +3, so she's going to draw 3 dots. She also has a -5. So on the negative side, she's going to have 5. Now, typically, I'll just have them all solid, but the reason why I'm drawing one solid red and one open circled is because you could imagine if you wanted to use the actual chips, the red chips and the yellow chips. Okay. So if you wanted to think about physical chips that you're doing. Okay. Here's how it works. We're going to circle the number of dots on each side that make 0. Remember, our focus is how do we get to 0? So if I have a +3, then a -3 would add up to 0. So these two are going to meet up to 0, go away. Okay. So if you want, you can just X them out as those are gone. And what is left is my answer. So my answer isn't just 2, it's also the side that it's on. So if I'm on the negative side, that's a -2. If those dots were left on the positive side, it's a +2. So here we've got -2 is my answer. Okay. It's fast. It's way easier and less complicated, I think, than the number line. Although the number line does have value. I'm not trying to bash the number line. But if we want them to be better at sort of arithmetic and seeing a pattern, they're going to see it from this. Okay, so let me show you. So let's say I wanted to find -8 + 3. Okay, you don't have to do the open circle and the closed circle. You could just do just all solid. So here's 8, 8 negatives, and then 3. And then I want to cross off one from each side. So here I've got 3 positives and 3 negatives are going to end up canceling out to 0. So this is my final answer. My final answer is 1, 2, 3, 4, 5, and it's on the negative side. So -5. What if the answer is positive? Okay. So over here we have a +9. So there we go. There's 9 dots. I'm going to have 7 negatives. Okay, great. And we can either count off one by one, but it looks like I'm going to have 7 matching on both sides. And then this is what I have left. So this one is going to be a +2. 2, and I'm on the positive side. Wait, you don't have to write positive. It's assumed to be positive if you don't write it. But if you have a student that ends up wanting to write it, sure, go for it. Okay. Remember that problem where we had a +2, a +8, a -11, and a +7? Okay, so you can do multiple cards. What you would do is just account for each dot where it needs to go. So like I have a +1, so that one I already wrote. And then I need -7, so let's write 7 over here. And then I need 4 more on the positive side. Okay, I got them all. All right, so it looks like I'm going to have 5 match up with 5. And now what's left is I have 2, and they're on the negative side. Okay. All right. So now let's talk about that standard algorithm because this is going to help them see it. So what they're going to start noticing is that the side with more chips is the answer, right? The meaning the side with more chips is the sign of the answer. So if I go back for a second, if I had more chips on the positive side, then my answer is positive. If I had more chips on the negative side, my answer is negative. So that's their first aha moment. Okay, well, what that is saying then is if the bigger number is positive, your answer is positive. If the bigger number is negative, your answer is negative. So again, the side with more dots is the sign. And you can just find out your answer by subtraction. So what they're going to notice is that, oh, wow, okay, if I had -8 and a +3, I know my answer is going to be negative. And I'm taking away 3. So really what they're doing is they're taking 8 minus 3 and getting 5. And their answer is going to be negative. So what is going to happen here is that this CHIPS method is going to have all those aha moments where they're going to start realizing their patterns and observations, and then they're going to be able to do the arithmetic in their head, hopefully. Not if they're still a little bit lower at recognizing the pattern, they can still use this method. It doesn't take that long and it's not that complicated. Okay. What about if we were adding all negative numbers? Well, what they're going to notice is that if they're adding all negative numbers, then all the dots will be on the same side. So if I'm adding -2 and -5, well, that means then I don't even have anything zeroing out. I just have a -7. So you are literally just adding the numbers and then tagging on the sign. So again, this CHIPS method may be a little bit of a sleeper, like it may not look that impressive, but it is a nice little quick tool. To me, it's a little bit faster than a number line because you don't have to put all that detail of marking stuff off and jumping and things, and they're going to have those aha moments of arithmetic. I hope. Okay. Awesome. That's it for adding integers. Woohoo! Try it out, see what you think. Maybe you prefer number lines. Go for it. The key is to give your students options and to see what they like. And if you need to watch this again, do it. But otherwise, I hope that it went well, that you're enjoying playing with integers, some simple integers. Yes, you can definitely use bigger numbers, but for the beginnings, we just want to stick with 1 to 10 and -1 to -10. All right. Until next time, I hope that everything is going well for you and learning math and working with students. And I hope you have a wonderful rest of your day. Good luck and just keep plugging along and trying math, okay? Bye.